Imagine a world transformed, a planet locked in a relentless grip of winter where the seas lay frozen, vast expanses of ice stretching endlessly beyond the horizon. This is not a distant dream but a chilling possibility of future Earth or an alien ocean world somewhere in the cosmos. Beneath these thick sheets of ice, life seems impossible. Yet, mystery stirs in the deep. How could anything survive when the temperature drops far below freezing, and the water that sustains life turns to solid glass? What secrets does this frozen abyss hold? This is the beginning of our journey into the forbidding realm of frozen oceans, where survival itself teeters on the edge between science and the unknown. Step by step, we unravel the eerie beauty and haunting adaptations that allow life to persist, and perhaps even thrive, beneath the ice's crushing embrace. The sight is stark and surreal. A planet wrapped in ice, oceans sealed away under miles of frozen crust, the dim glow of faint sunlight struggling through a trembling, cracked surface. The silence is absolute except for the soft, endless groan of shifting ice. This is no ordinary winter. It's a planet trapped in a permanent freeze, a globe hemmed in by cold beyond any known natural threshold. Yet, where we see lifelessness, nature might see only a beginning. Amid crushing desperation, evolution finds cracks of possibility. In the face of deathly cold and crushing darkness, creatures have adapted ways to keep their cells from shattering, to keep their blood from turning into lethal ice. But what if the adaptations go far beyond what we know? What if beneath that frost lies a world of beings so alien, they defy our deepest notions of life? Under the ice, life is hidden beneath a shimmering layer of mystery. To survive, creatures must keep their blood flowing even as the world around them freezes solid. This is where the antifreeze blood comes in, a biological marvel that prevents the formation of deadly ice crystals inside cells. It's not just a clever chemical trick, it's a lifeline for survival. Real terrestrial icefish in Antarctic waters already have antifreeze proteins which lower the freezing point of their blood. But one can imagine future or alien creatures that push this to extremes. Their blood might glow faintly, a translucent silicon-like fluid resistant to ice, coursing through veins that glitter like frozen rivers. Such adaptations signal more than survival. They hint at a radical reimagining of life's chemistry, where biology merges seamlessly with the frozen world around it. What does this mean for the creature's senses, their movements, or even their emotions? Could blood itself tell a story of endurance etched in the language of frost? Picture colossal beings moving beneath the ice, their bodies slow but purposeful, beating with a pulse almost imperceptible to human senses. Their blood is black, thick like syrup, defying freezing despite temperatures far below what we consider survivable. These creatures have evolved to live on a timeline measured not in seconds or minutes but in hours or even days. Their heartbeats slow and rhythmic, echoing in the silent void. Their skin is translucent, crystalline, glimmering with ghostly bioluminescence that flickers like distant stars. Watching them is like glimpsing ghosts trapped halfway between life and death, haunting their frozen prisons. These beings are not merely surviving. They embody a liminal existence, suspended at the edge of vitality and ice. What chilling mysteries lie hidden in their slow pulses? Are we witnessing a form of life that has transcended conventional biology or a cosmic horror playing out in frozen stillness? In the eternal darkness beneath the ice, predators have evolved in ways that challenge imagination. These hunters drift silently, listening for the faintest hints of warmth, the subtle thump of a distant heartbeat or the delicate ripple of metabolism. When prey is detected, the attack is slow but inevitable, a tide of gelatinous flesh engulfing all in its path. These creatures do not rush. Instead, they embody patient death itself, a living trap in a frozen wilderness. The horrifying beauty of their hunting methods reveals one truth. In a world where energy is scarce, every meal could sustain life for centuries. Predation becomes not just a fight for survival but a dance with death stretched across geological time. What can this teach us about resilience, about the quiet horror of life clinging to the last vestiges of warmth in a world of ice? Suddenly, the ice begins to crack, fault lines splitting the frozen ocean wide open. With the slow return of sunlight, the frozen world awakens. Microscopic life forms once dormant in antifreeze mucus start to stir, forming strange, otherworldly colonies. Yet, this thaw brings paradox too. As temperatures rise, the very antifreeze that preserved life turns toxic. Creatures adapted to survive deep freeze now face extinction or transformation. The environment is changing faster than life can keep pace. This unfolding drama is both awe-inspiring and terrifying. An ecological thriller where survival hangs by a brittle thread. How will these ancient, antifreeze-blooded beings respond? Will they evolve anew, or fade into the icy shadows of extinction? As warming continues, the legacy of the frozen ocean is written anew. Evolution's unending experiment presses on, reshaping and reinventing life's coding in the shifting seas. Some creatures mutate into forms barely recognizable. New life forms born from the cold's crucible. Antifreeze proteins once life-saving may one day enable life to emerge in unprecedented forms, blurring lines between biology and chemistry. This dance of mutation and survival invites us to imagine a future where life's boundaries dissolve and reappear in alien forms. Could our frozen mysteries today become tomorrow's evolutionary breakthroughs? Or do these specters of ice hint at deeper, darker secrets buried beneath layers of frost and time? Finally, the question lingers, did nature simply adapt to survive the cold, or did it create something alien and unknown? Beneath the frozen surfaces, life doesn't just survive. It thrives in ways beyond our comprehension. The frozen oceans are a haunting realm of biology and mystery intertwined, a place where the rules of life shift into a new, eerie language. What other secrets could such extreme adaptations reveal? And what lessons might this frozen narrative hold for understanding life in the coldest corners of our universe? The frozen seas invite us to peer deeper into the unknown, reminding us that life's endurance is astonishing, strange, and eternal. Deep beneath the groaning ice sheets of a world gripped by eternal winter, a profound silence reigns, broken only by the faint creak of shifting frost. Picture this frozen expanse. Oceans transformed into vast, unyielding vaults of ice, miles thick, where sunlight barely whispers through in ghostly blue hues. What force could have wrought such a cataclysm on a once thriving sea? Perhaps a rogue planet's gravitational tug or Earth's own axial wobble plunged these waters into subzero despair. In this desolate realm, the air, if there were any, would sting like knives, but down below, the true horror unfolds. Life, that stubborn force, refuses to yield entirely, hinting at adaptations so extreme they border on the unnatural. How does anything endure when every drop of water conspires to become a deadly spear? This frozen tomb challenges our understanding of survival, teasing secrets locked in crystalline silence. The planet's surface gleams like a shattered mirror under a weak, distant sun, cracks occasionally venting plumes of supercooled mist into the void. These oceans, once teeming with motion and color, now lie entombed, their liquid hearts stilled into rigid permanence. Temperatures plummet to realms where physics itself seems to falter, far beyond the limits that claim even the hardiest earthly explorers. Yet, in this apparent graveyard, faint tremors suggest otherwise. Movements too slow for eyes to catch, pulses too languid for hearts as we know them. Evolution, that relentless sculptor, has chiseled new forms from desperation's stone. What emerges defies intuition. Beings whose very essence laughs at the cold's embrace. Could such transformations twist life into something unrecognizably alien? The ice hides its truths well, but the mystery beckons us deeper. Beneath the crushing weight, the first whispers of life reveal themselves through blood that defies freezing, a viscous elixir engineered by eons of trial. Real-world Antarctic fish already wield antifreeze glycoproteins, binding to nascent ice crystals and halting their lethal spread through delicate tissues. Imagine these mechanisms amplified in future seas. Proteins that not only inhibit growth but reshape water's very behavior around them. No sharp crystals pierce cells here. Instead, a syrupy flow persists, glowing faintly with bioluminescent traces. This blood courses through translucent veins, mapping a network of endurance against the dark. But at what cost does such resilience come? Does it slow time itself within these creatures, stretching seconds into eternities? The subtle horror lies in this suspended animation, where life hovers perilously close to undeath. These colossal wanderers glide with glacial deliberation, their heartbeats resounding once every hour like tolling bells in an empty cathedral. Skin like living crystal refracts the scant light into eerie specters, illuminating forms vast and vaguely humanoid yet utterly otherworldly. Their metabolism crawls at rates unimaginable, conserving energy harvested from sparse chemical feasts amid the ice. Every motion conserves the precious spark against entropy's tide. In this realm, warmth is the ultimate predator, fleeting and fiercely guarded. What dreams, if any, flicker in minds attuned to such lethargy? The viewer can't shake the chill. Are these guardians of the deep or prisoners of their own ingenuity? Mystery cloaks them, heightening the dread of the unknown. Predators stir in the abyssal gloom, sensing not sight or sound, but the ghostliest warmth signatures pulsing faintly through the frost. They drift like sentient fog, drawn inexorably to the metabolic size of prey locked in stasis. No frantic chases mar this theater. Hunts unfold over days, methodical and merciless. Upon convergence, gelatinous tendrils unfurl, enveloping victims in a slow dissolve that spares no essence. Energy, that scarcest commodity, sustains victors for ages in this timeless freeze. Science marvels at the efficiency, yet horror whispers of a world where death arrives not in violence but inevitability. How finely tuned must senses be to detect life across such voids? The ice amplifies every unanswered question. Then, fissures spiderweb through the monolith above, heralding an awakening long dormant beneath the surface. Sunlight pierces tentatively, coaxing microscopic swarms from their mucus-shrouded slumber into bizarre aggregations. These primordial stirrings birth colonies that pulse with collective rhythm, their antifreeze legacy now a double-edged blade. As thaws encroach, proteins once salvific turn treacherous, poisoning fluids unaccustomed to flux. Creatures face a dire crossroads, adapt or perish in paradoxical warmth. The drama escalates, evolution racing against geochemical tides. What new monstrosities might arise from this turmoil? Tension mounts as the frozen idol fractures irreparably. Mutation races through lineages, birthing hybrids that straddle ice and liquid domains with unnatural grace. Antifreeze legacies seed biochemistries alien to our taxonomy, blurring organism and environment. Some lineages fade into legend, their forms etched eternally in ice cores as cautionary fossils. Others pioneer frontiers, their blood a blueprint for cosmic hardiness. This evolutionary churn evokes awe laced with unease. What boundaries of life have we glimpsed? The narrative of the deep questions humanity's place in nature's grand, indifferent experiment. Could such extremes echo on distant worlds, waiting discovery? Legacy endures, transmuted yet haunting. In the end, the frozen oceans pose an eternal riddle. Adaptation or abomination birthed from cold's crucible. Life persists not despite the ice but through its merciless forge, revealing resilience's shadowy underbelly. We've journeyed from stasis to stirrings, uncovering phenomena that thrill and terrify in equal measure. What further enigmas lurk in subzero vaults across the universe? These speculative seas remind us that survival's price may warp essence itself. The subtle horror lingers, a reminder of nature's capacity for the uncanny. Curiosity demands we probe onward, undeterred by the chill. In the abyssal cold of frozen oceans, life clings to existence through some of the most astonishing biochemical tricks nature has ever devised. Chief among these wonders is the phenomenon of antifreeze blood, an evolutionary marvel that allows creatures to survive where water itself crystallizes into lethal shards. Imagine a liquid that flows endlessly, even below the freezing point of saltwater, defying the natural laws that doom most life to perish. Antifreeze proteins, specialized molecules circulating within this blood, are the key players. Their job is to latch onto minuscule ice crystals as they begin to form, preventing them from growing into fatal structures that would shred cells and tissues apart. This molecular magic creates a shield that transforms the hostile freezing environment into a livable habitat. Yet, this survival strategy is not simply chemical. It's a gateway into a world where life and ice intermingle in an eerie dance of existence and annihilation. Though it sounds like the stuff of science fiction, antifreeze proteins are very much a biological reality. They have evolved independently across a variety of cold-dwelling fish species in the Arctic and Antarctic waters, including notorious players such as Antarctic icefish and Arctic cod. These proteins work in subtle, complex ways, attaching to the tiniest imperfections in ice crystals and effectively capping their growth. Unlike commercial antifreeze, which lowers freezing points in a straightforward manner, these natural proteins intricately regulate ice formation by controlling its shape and inhibiting recrystallization, where dangerous ice crystals would otherwise become wider and more destructive. The result is a delicate balance, keeping the creature's body fluids liquid even in temperatures that would otherwise spell death. What evolutionary pressures could have driven the creation of such precise molecular tools? Beyond the proteins themselves, the creatures wielding this antifreeze blood sport a suite of other extraordinary adaptations. Take the Antarctic icefish, for example, which lacks red blood cells entirely, an adaptation unheard of in most vertebrates. Instead, their blood is almost transparent, carrying oxygen dissolved directly from the frigid waters. This lack of hemoglobin might sound like a recipe for disaster, yet these fish thrive because cold water naturally holds more dissolved oxygen. To compensate, their bodies have evolved enhanced blood volumes and larger hearts pumping slower yet more powerful beats, all tailored to function at near-freezing temperatures. Moreover, these fish possess genomes packed with genes dedicated to resisting cold-induced cell damage, highlighting just how deep the adaptation runs. How can such paradoxes, blood without red cells, life without warmth, reshape our understanding of biology? The story grows stranger when you consider the biochemical costs and evolutionary trade-offs antifreeze proteins entail. These molecules, while life-saving, impose metabolic burdens and can interfere with cellular functions if expressed excessively or in fluctuating thermal environments. For some species, this means they must finely regulate protein production to avoid collateral damage, a balancing act between survival and self-harm. Fascinatingly, the activity and gene copy number of antifreeze proteins vary among populations depending on how often freezing temperatures occur, underscoring evolution's nuanced response to environmental challenge. Some fish species have seemingly turned down their antifreeze potency where freezing is less constant, while others expand their genetic toolkit for maximum protection. The varied landscape of Antarctic and Arctic seas acts as a natural laboratory for evolution's most intricate experiments. On a microscopic scale, the antifreeze proteins don't just stop ice from spreading. They also alter the physical properties of body fluids. These proteins raise the melting point of ice slightly, a paradox known as thermal hysteresis, creating conditions where ice can supercool without crystallizing. Imagine a winter landscape where ice exists in a state of suspended animation, neither melting nor freezing fully. This is the internal reality for these creatures. The protein's binding surfaces adapt specifically to the shape of ice crystals, changing standard crystal formation patterns into ones less harmful to cells. Scientists who study this mechanism uncover a glimpse into nature's extraordinary capacity to manipulate fundamental forces like freezing, a reminder that life can sculpt matter itself to its needs. Such feats provoke deep curiosity. What other possibilities lie undiscovered in the dance of molecules and ice? The antifreeze blood and its associated adaptations suggest a kinetic, ever-adapting evolutionary environment beneath frozen seas. These adaptations are not static solutions but ongoing dialogues between changing climates and life's resilience. Some Antarctic fish, like the crocodile icefish, have evolved not only antifreeze blood but also enhanced respiration strategies such as greater gill surface areas and even oxygen absorption through their scaleless skin, compensating for their unique blood chemistry. This highlights how interconnected biological systems evolve in concert. Life here is a study in pushing limits, rewriting traditional rules about what is possible. What other symbiotic or physiological marvels await discovery in these frigid depths, hidden beneath ice and silence? But along with wonder, there's a shadow of vulnerability. Life adapted to frozen oceans hinges precariously on stable, cold conditions. Rising temperatures threaten to unravel this delicate antifreeze balance. As oceans warm and oxygen availability shifts, creatures relying on dissolved oxygen and these specialized proteins may find themselves gasping in a changing world. Their highly specialized adaptations may become fatal liabilities, unable to keep pace with rapidly fluctuating climates. This looming existential threat adds a dose of real-world tension to an already mysterious adaptation saga. Could these antifreeze bloodlines disappear, lost to warming seas, or will new evolutionary chapters emerge from the thaw? Ultimately, antifreeze blood is more than a survival mechanism. It's a story of molecular finesse, biological innovation, and the tenacity of life in its most extreme forms. It questions what life truly means when all familiar signs of vitality are dialed down to near stillness. These frozen seas challenge the limits of science, blending mystery and marvel into an icy narrative where every drop of blood pulses with enigmatic purpose. The story invites us to reconsider the fragile, resilient borderlands between life and death, warmth and ice. What if, beneath distant alien oceans or Earth's frozen fronts, similar tales unfold, telling of life's uncanny will to endure? Deep in the shadowed vaults of frozen oceans, where light fades to nothingness and cold seeps into every crevice, survival demands more than mere endurance. It requires reinvention. Antifreeze blood courses through veins of creatures forged in this icy crucible, a viscous serum that laughs at temperatures that would shatter ordinary life. These proteins, evolved from humble origins, bind relentlessly to nascent ice crystals, halting their deadly expansion with molecular precision. Picture the scene. Tiny ice seeds enter the body from frigid waters, only to be ensnared and immobilized, preserving the fluid state of blood against all odds. This isn't passive defense. It's an active war waged at the cellular frontier. Yet, whispers of unease accompany this triumph. What price does such defiance exact on the soul of these beings? Do they feel the chill more acutely, or has numbness become their eternal companion? The mystery thickens as we delve into blood that pulses with forbidden resilience. Real-world Antarctic notothenoids offer a glimpse into this enigma, their antifreeze glycoproteins and potentiating proteins standing as evolutionary sentinels. These molecules adsorb to ice surfaces, creating a thermal hysteresis that separates freezing from melting points, trapping crystals in limbo. No jagged spears pierce delicate membranes here. Instead, a syrupy equilibrium prevails, even at -2 degrees Celsius. Imagine the blood's glow, faint and ethereal, illuminating translucent flesh in the abyssal dark. This adaptation spans species, from sluggish bottom dwellers to nomadic wanderers, each tweaking the formula for their niche. But evolution's handiwork carries shadows. Proteins that save can also superheat ice, resisting seasonal thaws and risking lifelong accumulation. How do these creatures navigate such double-edged salvation? The subtle horror emerges in their silent vigil against encroaching frost. Envision colossal forms gliding through the gloom, their heartbeats echoing like distant thunder. Once every hour, a languid affirmation of life. Skin of crystalline gel shimmers, veins tracing rivers of antifreeze elixir that defies solidification. Metabolism slows to a crawl, each calorie stretched across eons, harvested from scant hydrothermal vents or chemosynthetic feasts. No frantic scurrying mars this realm. Motion is deliberate, a poetry of preservation. Bioluminescence flickers sporadically, signaling to kin or luring prey in the void. These beings embody stasis, teetering between vitality and oblivion, their forms both beautiful and grotesque. What consciousness inhabits such temporal vastness? Dreams elongated into geological epochs. The ice amplifies the dread of isolation, where every pulse questions the boundary between alive and merely not dead. Predators lurk in this suspended world, attuned not to sight but to the faintest thermal whispers emanating from prey's sluggish cores. They drift as amorphous clouds, gelatinous masses propelled by imperceptible contractions, homing in on metabolic heat signatures. Detection spans kilometers, a sixth sense evolved from desperation's forge. The hunt unfolds in agonizing slowness. Days of patient convergence culminating in envelopment, tendrils dissolving flesh into sustenance. No blood spills in violence. Absorption is total, efficient, eternal. Victims' antifreeze blood mingles with victors, perpetuating the cycle in frozen harmony. Does terror grip the pursued in their torpor, or has instinct numbed all fear? This choreography of death evokes a primal chill, life's ledger balanced on scarcity's knife edge. As eons grind onward, the ice's grip falters, cracks spiderweb overhead, admitting slivers of long-lost light. Microbes awaken first, swarming in mucus veils laced with residual antifreeze, birthing colonies that pulse with alien rhythm. Larger forms stir uneasily, their blood protesting the thaw's betrayal. Proteins optimized for deep freeze curdle in rising warmth, turning lifesavers into toxins. Evolution scrambles, mutations racing against geochemical tides. Some perish in paradox, entombed anew by their own defenses. Others transmute, birthing hybrids suited to flux. What agonies accompany this rebirth? Pain amplified in slowed nerves. The awakening sea becomes a cauldron of horror and hope, where yesterday's saviors spell tomorrow's doom. Zooming out, the frozen legacy reshapes oceanic biomes, antifreeze remnants seeding novel chemistries across phyla. Proteins once confined to blood now lace exoskeletons, enabling armored behemoths to roam ice-liquid interfaces. Symbioses form between hosts and microbes, sharing cryoprotectant burdens in mutualistic webs. Genomic expansions amplify cold-hardy genes, echoing notothenoid precedents on a grander scale. Yet vulnerability lingers, specialization breeds fragility against unpredictable climates. Warming pulses threaten cascades, from microbial blooms to apex extinctions. Could these adaptations foreshadow interstellar life, hardy against cosmic voids? The narrative pulses with uncertainty, life's gamble in eternal flux. Contemplate the paradox at this world's heart. Antifreeze blood as both liberator and jailer, enabling persistence yet courting peril. Superheated ice crystals, stabilized by proteins, accumulate silently, occluding vessels and straining physiology. Seasonal melts falter against this inhibition, dooming some to crystalline burdens carried lifelong. Energy diverted to maintenance saps vigor, a metabolic tax paid in shadowed vigor. Still, resilience prevails, a testament to evolution's cunning indifference. What inner worlds do these burdened giants inhabit? Resignation or defiant spark? The mild horror lies in this intimate invasion, ice as unwelcome tenant within flesh. In the end, Antifreeze blood unveils nature's arcane artistry, blending salvation with subtle menace in frozen depths. We've traced its mechanisms from molecular binding to ecosystem ripples, marveling at tenacity amid terror. Questions linger like frost on glass. What further secrets guard these abyssal realms? Might earthbound analogues hint at exoplanetary biospheres thriving in eternal night? The unknown beckons, stirring awe laced with dread, reminding us life's extremes blur familiar lines. These speculative seas challenge complacency, urging deeper probes into cold's embrace. Endurance here is no mere trait. It's a haunting symphony of survival's shadowed poetry. Imagine the frozen ocean's eternal vigil, suddenly shattered by a deep, resonant crack echoing through the ice. Fault lines spiderweb across the vast ceiling above, allowing tentative shafts of sunlight to pierce the abyssal gloom after centuries of darkness. This is the awakening, a thawing that stirs the slumbering giants below into uneasy motion. Microorganisms, long encased in antifreeze-laden mucus, begin to twitch and multiply, forming pulsating colonies that glow with nascent life. The water, once a solid prison, now sloshes with precarious fluidity, challenging adaptations honed for absolute zero. What horrors does this change unleash on creatures perfectly tuned to stillness? The paradox unfolds. Salvation from cold becomes peril in warmth. As the sea stirs, the mystery of transformation grips us tight. These primordial stirrings ripple outward, birthing bizarre aggregations where single cells fuse into throbbing mats that carpet the seafloor. Antifreeze mucus, once a shield against ice invasion, now oozes thickly, binding communities in a slimy web of survival. Sunlight filters deeper, igniting chemosynthetic feasts long dormant near hydrothermal whispers. Larger forms sense the shift, their glacial heartbeats quickening ever so slightly in response. Yet, tension mounts as blood proteins, masterful at subzero stasis, falter in rising temperatures. Crystals they once corral begin to destabilize, threatening cellular chaos. Do these beings feel the first pangs of betrayal from their own biology? The awakening sea whispers of doom disguised as renewal. Colossal inhabitants, with their syrupy black blood, confront the thaw's insidious creep. Antifreeze glycoproteins, evolved to bind ice invaders, now clog pathways as warmth disrupts their grip. What was a harmonious freeze avoidance turns toxic, proteins denaturing into lethal aggregates that choke vital flows. Metabolism, long suppressed, surges unpredictably, demanding energy in a world still sparse. Skin once crystalline now softens, exposing vulnerabilities to newfound currents. The horror lies in this reversal, life's greatest triumph inverting into quiet suffocation. How do senses, dulled by eons of cold, register this thermal assault? Evolution races against the melting clock. Predators, those patient drifters of darkness, find their strategies appended in the flux. Thermal signatures, once faint beacons, blaze brighter amid the stir, drawing hunters into frenzied convergence. Gelatinous forms accelerate, tendrils lashing with unaccustomed speed against prey roused from torpor. Hunts compress from days to hours, a chaotic ballet of consumption in thawing chaos. Energy windfalls from blooming microbes fuel this rampage, yet overstimulation risks exhaustion. The mild dread builds. What becomes of hunters when scarcity flips to glut? Colonies below teem, offering feasts that mask deeper instabilities. The sea's rebirth pulses with predatory urgency. Deeper still, the paradox sharpens into existential crisis for antifreeze-blooded lineages. Proteins inducing superheated ice in cold now precipitate in warmth, occluding vessels like insidious plaques. Real Antarctic notothenoids face similar shadows, their antifreeze glycoproteins risking lifelong crystal burdens even in summer thaws. Here, scaled to speculative extremes, entire physiologies teeter on obsolescence. Mutations flicker in gametes, promising hybrids with dual-domain resilience or condemning pure strains to fade. Warming accelerates beyond adaptive paces, geochemical tides overwhelming genetic response. What silent agonies course through nerves awakening too late? Transformation beckons, laced with extinction's chill. Microbial mats evolve into macrostructures, towering reefs of mucus and filament that anchor the awakening ecosystem. These living lattices filter nutrients, stabilizing fluxes for larger migrants. Symbioses bloom, microbes trading cryoprotectants for shelter in host tissues. Sunlight fuels photosynthesis in surface layers, oxygenating depths long anoxic. Yet, instability reigns. Abrupt chills refreeze mucus into brittle traps. Creatures navigate this volatile interface, some thriving as boundary dwellers, others perishing in mismatches. Does intelligence emerge in this turmoil? Collective minds pondering the thaw? The narrative swells with awe and apprehension. As cycles of freeze-thaw etch new paradigms, the frozen legacy fractures into diverse trajectories. Some lineages perish spectacularly, their blood curdling into iridescent grave markers drifting in currents. Survivors mutate boldly, antifreeze genes repurposed for hypertonic regulation or venomous defenses. Ecosystems rewire, predators yielding to grazers in planktonic booms. Genomic expansions echo earthly icefish, bolstering antioxidants against oxidative thaw stress. Vulnerability persists, specialization a gamble in climatic roulette. What alien morphologies arise from this crucible, winged gliders or burrowing titans? Hope mingles with horror in evolution's forge. This awakening sea etches a haunting lesson. Adaptation's triumphs harbor hidden dooms. Antifreeze blood, forged in ice's merciless school, confronts warmth as its nemesis. We've glimpsed the stirrings, the paradoxes, the rebirths that thrill and terrify. Questions linger like cracking ice. Can life pivot fast enough? Or does the thaw claim its toll? Mysteries abound in these speculative depths, mirroring potential fates for our own warming world. The unknown vastness beckons, stirring curiosity laced with dread. Endurance persists, but at what transfigured cost? As the timeless frozen oceans begin their slow transformation, the legacy of Antifreeze Blood becomes a story of profound evolutionary upheaval and innovation. These extraordinary proteins, which first emerged millions of years ago to safeguard life in subzero waters, continue to shape the fate of these creatures amidst shifting climates. Recent studies reveal that antifreeze glycoproteins in Antarctic nototheniod fish evolved from an unlikely ancestor, a pancreatic digestive enzyme called trypsinogen. This remarkable evolutionary leap repurposed existing genetic material into a potent protector against freezing, illustrating nature's resourcefulness in the face of dire environmental threats. How does such a transformation happen at the molecular level? By recruiting segments of the trypsinogen gene and amplifying short repetitive sequences, new genes capable of producing crucial antifreeze proteins emerged, enabling these fish to survive and thrive in increasingly hostile seas. Convergent evolution deepens the mystery. Unrelated fish species from opposing polar regions independently developed remarkably similar antifreeze proteins. Antarctic notothenioids and northern cods, though separated by vast distances and evolutionary paths, both evolved glycoproteins that bind ice and prevent fatal crystallization. This fascinating parallel, arising from different genomic sources and ancient divergence, highlights the strength of natural selection in extreme environments. With each lineage sculpting unique genetic architectures for similar biochemical outcomes, evolution displays both ingenuity and predictability. What implications does this convergence have for understanding life's potential on icy exoplanets, where similar pressures might mold alien biochemistries? Genomic studies reveal that nototheniod antifreeze genes form large families encoding multiple protein copies linked together as polyproteins. These complex structures are post-translationally cleaved into functional units, an elegant mechanism that magnifies the production of life-saving antifreeze molecules. Evolution has honed this system, enabling rapid responses to environmental shifts by gene duplication and variation. This genetic plasticity fueled the radiation of Antarctic fish into diverse niches, including pelagic, benthic, and surface habitats once foreclosed by lethal cold. Here, antifreeze proteins did not merely preserve life. They unlocked new ecological opportunities, helping to fill empty icy waters with thriving ecosystems. Could such molecular adaptations have catalyzed similar evolutionary explosions elsewhere in the universe? Antifreeze protein evolution weaves a tale intimately tied to Earth's geological past. The genes arose during the Miocene epoch, approximately 10 to 14 million years ago, coinciding with the onset of Antarctic ocean cooling. As temperatures plunged, selective pressures for freezing avoidance spiked dramatically, sparking genetic innovations that enabled benthic ancestors to radiate across previously inaccessible habitats. Intriguingly, other polar species display different types of antifreeze proteins, reflecting multiple independent origins of ice-binding molecules across a broad taxonomic spectrum. This diversity underscores the universal demand for molecular defenses against subzero injury and the myriad evolutionary solutions found. What else might our planet's deep past reveal about the origins of life's biomolecular toolkit? Despite their extraordinary efficacy, antifreeze proteins carry evolutionary trade-offs. The metabolic cost of producing large quantities of these proteins, potential interference with other cellular functions, and the danger of crystal accumulation during seasonal thaws all impose burdens on these organisms. Balancing these costs requires precise gene regulation and adaptive plasticity, reflecting a dialogue between organism and environment that unfolds over millennia. As present-day oceans warm, these fragile balances face unprecedented challenges, threatening to upset finely tuned adaptations. Will these ancient proteins allow survival in a rapidly shifting world, or will they become evolutionary relics of a harsher age? The ongoing dance between genetic innovation and environmental flux raises profound questions about resilience. The story of antifreeze protein evolution in Antarctic fish resonates far beyond biology, inviting reflections on the fluid borderlands between adaptation, survival, and extinction. These proteins are molecular sentinels guarding life against the paralyzing grip of ice. Their evolution a testament to life's tenacity in extreme conditions. Simultaneously, their complexity hints at inherent vulnerability, a reminder that no adaptation is without limits. As glaciers recede and ocean currents alter, the very biochemical shields that once guaranteed survival now face existential obsolescence. This paradox paints a haunting picture of evolution's double-edged nature. Innovation inevitably intertwined with fragility. How might future genetic shifts allow creatures to rewrite their own fate in these once frozen seas? The evolutionary saga of antifreeze proteins also highlights the power of genetic innovation through gene duplication and functional diversification. Existing genes, like trypsinogen, don new roles through subtle changes and expansions, crafting entirely new proteins from old templates. This process exemplifies evolution's capacity to repurpose and innovate with remarkable efficiency, particularly under extreme selective pressures. The generation of large gene families encoding multiple protein variants fosters versatility and adaptability within populations, allowing rapid responses to environmental variation. Could this mechanism serve as a blueprint for engineering synthetic proteins or designing resilient biomolecules for biotech applications? Understanding natural evolutionary experiments unlocks possibilities for future technological advances inspired by nature's ingenuity. Ultimately, the legacy of Antifreeze Blood is a narrative of transformation, where frozen worlds become crucibles for genetic creativity and biological renewal. Life not only survives but reinvents itself, pushing boundaries beyond what was once imaginable. Through antifreeze proteins, creatures bridge the gap between ice and liquid, stasis and motion, death and life. This interplay of molecular adaptation and environmental challenge charts a timeless story of evolution's relentless creativity in the face of catastrophe. How might similar tales unfold beneath the ice of distant moons or isolated exoplanets? The questions linger, wrapped in the quiet mystery of life's frozen frontiers, urging curiosity and wonder as we peer into the unknown.